Now, as we start chapter 4, the first thing we want to address is this concept of what's called a radian. So I'm going to walk you through this activity of discovering what a radian is exactly. So the first thing we do is we're going to take 7 round objects and put them in a line on a piece of paper. And this is going to mimic the radius of a circle that we're going to be drawing. So if I do that and lay those down, you can see that I have 7 M&Ms. So I'm going to come on in here and I'm going to mark those off. And then with that, I'm going to draw the radius length that represents those M&Ms. So now what you've seen is I drew the radius here of a circle that I'm going to make. So now I want to use a compass, and I'm going to actually have this be the inside of my circle, the center. This is going to be the outside of my circle. I'm going to come on in here and I'm going to draw the circle that gets created using this radius length as my shape. So now what you see in front of you is a circle that was drawn using the radius length of my 7 different M&Ms. Now, what I'm going to do here is I'm going to take the 7 M&Ms that represent the radius of this, and I'm going to start on the outside of the circle right here. And I'm going to take those M&Ms and actually have them drive kind of along the outside or the circumference of the circle. And when I do that, what you're going to see is I took the actual radius length of that circle and I put it on the outside. I'm going to tick mark that right there. So keep in mind what I just did is I took this length right here that was the radius, and I took it and I laid it out right here on the outside of our circle. So what I just did is I put the radius, which was here, and I just laid it out right here. So this is also the radius. What I just did is I created what's called a radian. So this here, this arc that we're seeing is the same length of the radius, and it is called 1 radian. So here's my question for you. If I took the 1 radius and I laid it outside of the circle and it landed here, how many radii is it going to take me to go from the start here to go all the way around and to end right here? I want you to think about how many times do you think I have to lay out the 7 M&Ms. As here's another one, lay them out straight on the circumference. I'm going to tick mark it, and that's going to become a second radius for me. So that means if I combine this second arc radian in this one here, what I now have in the blue is going to be 2 radians, which basically just means it's the radius length laid out on the circle 2 times. So I'm going to have you pause this video and just think about how many lengths is it going to take me to go again from the start all the way to the end. And I want you to do this in terms of thinking about our 7 M&Ms that we have here. Exactly how many radius lengths of the M&Ms will it take to do that? Now, if you do it from start to finish, what you're going to find is it's going to take exactly 6 complete radius lengths plus an additional 2/7. And again, I know that's going to be 2/7 because it took me 2 more M&Ms of my 7, so it's 2/7. So what we've just discovered then is a full circle has an approximate rate, or exact radians, I should say, of 6 2/7. And we know the full circle from start to finish is called circumference. So I'm going to say that the circumference of this circle, when measured in radians, is 6 2/7 radians. Okay, now I want you to think about what do we know about circumference when it comes to the geometry? Well, we know the formula for circumference is 2 pi r, where r is the radius. Now, what do we know about the number 6 2/7? If you put 6 2/7 into your calculator, you're going to get that it's approximately, because now I'm rounding, is 6.2857. That is the rounding number. So it's approximately 6 in 6.2857 radians around a circle. So really that's 6 times and then about almost another 28 to 29% around the circle. So now take a look at that number, 6.2857. When I really look at it, this number here pops out to me, 6.28. Well, here's my question for you. Pi is the number in math. It's irrational because it doesn't round naturally. And if we do round pi, though, remember pi is about 3.14. So if I do an approximation of this is approximately 2 times 3.14. And if you do that, you're going to get approximately 6.28. So what we're noticing here is there's a connection. The radius length went around 6.28 times, but the number 2 pi, when we round, we get 6.28. So what we've just discovered here is that the 6.28 approximate radians is exactly the same thing as 2 pi. So again, the radius length, it took that radius 6.28 times to go around the circle. Now in trigonometry, we don't tend to say 6.28 radians as much. We like to speak in terms of pieces of pi. Well, that is the same as 2 pieces of pi. So let me show you this connection though. What about the radius of this circle? What is the radius of the circle so that we know the circumference would be considered 2 pi? Well, to make that happen, the radius would have to equal 1 unit. And our unit here is the length of our 7 M&Ms that we used. So what this is called the unit circle. And it's the unit circle because the radius is assumed to be 1. And even though our radius length was made up of 7 M&Ms, it was 1 complete length of M&Ms, so it's considered 1.